In the SaberRD Experiment Analyzer Introduction, we learn an experiment is the definition of the steps to take to test if a design meets performance criteria. These steps include performing simulation analyses, iterating through analyses with variations applied to the design, graphing results, measuring results, and performing other tests and calculations. Let's take a look at how experiments are created. To begin, move the mouse over the Experiments tab on the right hand of the screen. When the Experiments tool is displayed, the list of previously created experiments is shown. This tool also has an icon for creating a new experiment. When you create a new experiment, you will be prompted for information about the experiment you will create. Type in an identifier that does not contain spaces. By default, the name that is displayed in the Experiments tool will be the same as the unique identifier, but it can be changed and can contain spaces. You can also create categories of experiments to organize them. For this example, we will not place the experiment in a category. Lastly, you can enter a description for the experiment that will show up in the tooltip for the experiment when you mouse over it in the Simulation tab. Once this information is entered, a blank document will be created and a context-sensitive tab will appear in SaberRD's ribbon. This tab contains the different tasks that can be added to your experiment. To add a task to the experiment, select the desired task in the ribbon. This will automatically add a line to the experiment. The task that is placed in your experiment can now be configured for your design. The key properties can be added directly inline in the experiment. For a transient analysis, these properties include the end time and the time step. We will change the end time to 5 milliseconds. If you would like to modify additional properties of the task, they can be edited in the Properties tool on the right. For iterative tasks, the task will contain a body. The tasks that are added to the body of the iterative task will be performed for each variation of the design that is specified by the iterative task. For example, a parametric sweep can be added to the experiment. The key properties of this task are the parameter in the design to change, the beginning value of the parameter, the ending value of the parameter, and the increment to change the value by. In this example, we will choose to change a capacitance value from 1M to 4M with an increment of 1M. To perform a transient analysis for each of these variations, a transient task should now be added to the body of the parametric sweep task. This can be done by placing a new transient task, but since I already defined a transient task, I will simply click and drag the existing transient analysis into the parametric sweep body. Once the analyses have been defined in the experiment, tasks can be added to view the results. The first step is to create a graph in which to view the results. Multiple graphs could be entered into an experiment. Once a graph is defined, signals to view can be added to the graph. The Experiment Editor window will provide you with a list of signals that are currently defined in the experiment. It will give you the option to select a signal from analysis that is defined in the experiment, and it will also give you the option to browse for a signal from a plot file that is saved on disk. For this example, we will show the signal named DC_out from the TR analysis that was performed inside of our parametric sweep analysis. A measurement could also be performed on the results and displayed within the graph. To change the type of measurement, click on the @X and select the desired measurement. Since the result that we were measuring has a waveform for each variation of the design, the result of the measurement will be a waveform where the x-axis will be the value of the parameter that was changed and the y-axis will be the value of the measurement. The icon in the experiment will change to indicate that the result is a waveform. This waveform can now be displayed in the graph. We can then perform another measurement to find the maximum of the overshoot for the variations on this design. In another video, details will be provided for how to use measurement and test tasks to build up pass-fail reports to see if the design meets a specific performance specification. Now that the new experiment has been created, it shows up in the Experiments tool, and it can also be used when running simulations from the Quick Simulation tab in the SaberRD ribbon. When the experiment completes execution, the graph will be available for viewing in the Results tab on the left. As you continue to explore SaberRD's Experiment Analyzer, look for additional videos that provide detailed instructions for how to manage experiments associated with a design, performing fault analysis with the Experiment Analyzer, using variables within the Experiment Analyzer, and using the Experiment Analyzer to build up pass-fail reports.